kind of being less active. So welcome everyone, and obviously welcome to those online as well. So I wanted to take a slightly different approach really. I didn't want to just talk about product. I know we've had a lot of PowerPoint already. So I want to talk about, at least for half of this presentation, the market challenges, because that really makes the value of what we're going to talk about make a lot more sense. So my title of my presentation is Delivering the Edge. And it's excuse me, a little play on words there. So I think it's fair to say, certainly even after COVID, we're having to change the way we work. Nothing's going to quite go back to normal. And during those COVID days, there were a lot of distractions, right? So maybe an uptick in caffeine can help focus, and how can we really kind of stay focused on what we're looking to do? There's some relevance to on this as we move forward. But Hugo Gernsback was a prolific inventor. And he was also an editor, and obviously we have some editors in the room today. Yeah. And this isn't a prize giveaway, by the way, and it wasn't particularly effective either. So this is the isolator helmet, patented back in 1925. So maybe if you watched the football last night, this could have helped reduce some noise, but ultimately what Hugo Gernsback realised was that our distractions aren't external. Most of the time we distract ourselves internally. So even though we try and drown out external distractions, excuse me, what's really confusing us is ourselves. We can really kind of interrupt ourselves a lot of the time. So I'm going to do a little experiment. Again, I want to kind of try and make this resonate with people in the room when we talk about things like distance and latency and all these technical terms. How can we relate to them? So in a minute, we're just going to play a short video, and what I'd like to do is watch the video. It's a little bit interactive. There's going to be a passing of a ball, and the instructions will come up in just a moment on the YouTube video. Please kind of pay attention, count the amount of time the ball is passed by those, and I think it's a white t-shirt, but the instructions will come up just now. Okay, and just start the YouTube video.
Count how many times the players wearing white pass the basketball. How many passes did you count?
15. Anyone else?
40.
Anyone else? 16. Just before we let you know how many passes were made, I'm going to ask a question very quickly, and if you've seen this before, you may know. Did anyone see the gorilla? Put your hand up. Yeah. So maybe in the room, maybe less than 20% of people saw the gorilla. So if you just play the video again.
The correct answer.
And you won't believe this. This is the same video at the same speed. So watch again.
Did you see the gorilla?
Yes.
This is real time, right? This is not slowed down at all.
This video is from research by Daniel Simons and Christopher Chabris and is copyrighted.
Thank you. So very quickly, what are we trying to demonstrate here? First things first, look, computers can't multitask, humans can't multitask. What we can do is switch between tasks really quickly, okay? And switching between tasks and distance relate back to latency, so this is delay, okay? So if you want to reduce delay, you can reduce the amount of hops to equipment. That's creating a lot of latency, okay? And also the distance between a data center can increase latency as well. So we're going to talk about latency in just a moment, but I wanted to make it kind of relatable. Again, I was driving the car with my wife, I was fiddling with some sat nav, she was in a panic. I'm like, I'm okay with this, look, I can do this. And she said, no, don't do that. So ultimately, we can switch between tasks very quickly, but it can be dangerous as well. Hopefully a little bit of fun to help you kind of relate to the fact that we can try and multitask, but there is a delay to doing that. So don't internally disrupt yourself. External factors don't hit you as hard as you think they will do. And yeah, it's interesting to see. When we play that video, sometimes half the room sees it, half doesn't. So it's always a nice, really interesting experiment to run. If we just pop back to the slides. Here we go. So there's a lot of definitions in terms of what the edge is. So essentially, summary of fact, some people joke and say if you get to the edge, you kind of fall off, and no one knows what the edge is like. So organisations, quite simply, are working hard to place power and compute closer to where those resources are needed. We could talk about edge all day long. We're limited for time here today, but a quick summary. But the great news about the edge, I guess a couple of things. We hear about machine learning, artificial intelligence, and internet growth. But that overall internet traffic growth is growing in the mid to high 20s as a compound annual growth rate over the next 5 years. So it's growing double digits, which is great. Especially if you're in the industry, we want to have jobs for some time to come. So a fantastic industry to be in, right? But machine to machine, east to west traffic that's in the data center, that's growing at almost double the rate. 44% compound annual growth rate. They're the kind of numbers we're seeing. So huge growth in data center traffic in the data center. There's other factors driving high speeds, the fiber, for instance. So they can be architectural changes within the data center. So we're moving from need for 400 gig to 800 gig, and in the future 1.6 terabits. So to get lowest cost per gigabit, power efficiencies, and support bandwidth in the data center, things are going to get a lot faster. But when we look to 5G and the edge, a lot of people thinking, is this now, is this in the future, where are we with this? So we did actually support edge projects, and we'll talk about those in just a moment. But essentially, where does the edge start and where does it finish? So you have the kind of far side edge, also the near side edge. So that can be small cells, in street cabinets, in lampposts, etc. Macro cells, back at the cell site, going to maybe mobile switching centres. This could be a central office type arrangement. And back to data centres. This is an ecosystem. So some people say, is the data centre dead? Simply no. What's happening is that this whole ecosystem of increased bandwidth, which is always zettabytes, yeah? So, or zettabyte era. So, at the moment we're around about 80 zettabytes, and in the future, next by 2025, they're forecasting 175 zettabytes. So this is a huge amount of data. So everyone's going to grow. We're going to have jobs for a long, long time. But essentially, what's needed here in terms of the physical infrastructure? Well, fiber's going to get more dense. There's going to be need for low power and low cost per gigabit. Things need to get more automated. If you've got all these areas of the network to service, how can you do that more efficiently? In monitoring, lights off type data centers, they're going to become more and more important. And obviously more secure as well. That's typically a top spending priority. So again, if you kind of move all the way back, regardless of the area of the network, these priorities are typically very much the same. And we talked about Panduit today, Panduit. Panduit's heritage is about solving cable management challenges, and that's really what we're doing here. So this is a great opportunity for all of us in this room in terms of being in the industry. And this is also a great opportunity for Panduit, feeding this growing infrastructure. So, Gartner released the hype cycle. So, we all get excited, the press can hype things up, and actually there can be a delay to those things happening. So you have things like the proper disillusion, and this is a hype cycle diagram. And I'm not touching all these points in here. This is here as a reference, but essentially, if you look at autonomous vehicles, we have to put the infrastructure in place to support this now, but actually the technology really may not become mass market for 10 years. But driving cars that are automated is great, right? You can sit down, do some work, but ultimately, is it going to really help the earth as we know today? It's going to improve our lifestyle, but not dramatically change things. But AI is going to really drive some great positive things as well in terms of the healthcare industry. If you look, in terms of drug discovery, it takes 12 to 14 years to bring a drug to market. A third of that is the discovery phase. Yeah, so by 2025, 30% of new drugs will be discovered by AI techniques. And that will bring that discovery phase, which is a third of that time scale, crashing right down. So this is going to help us bring cures to market much faster. So as well as these kind of fun things like VR, it's going to help us sell and have fun. There's some real kind of fundamental advantages to humanity as well. Ways to these little icons, you can click on the link and there's more information should you want to follow that. So just another example. We've seen the Terminator, this is Robocop, yeah. And maybe 20 years ago, even longer, this was on TV and we thought, this is cool, right? It looks cool. But the reality is, the real Robocop doesn't look quite as cool. I mean, he's a bit more like a garbage can, doesn't he? But the interesting thing is the business case really does stack up. So essentially for the price of a US police officer, or maybe a little less, this garbage can was fighting crime, recording, creating data, and essentially it was a part of a smart city. It was a pilot project, but actually it created some very positive results. So these case studies will become market reality, and I'm sure they're evolving. There's maybe something close to Robocop, hopefully. But essentially, today's networks support applications in terms of latency of 10 milliseconds. Yeah? Tomorrow's applications to work in real time, it could be autonomous vehicles, it could be this type of technology, really need to be working at 1 millisecond. And today's networks will not support that. So this is what's driving the edge, this is what's driving 5G development, it's going to drive our businesses over the next 10 years. Of course, if this thing had to climb the stairs a bit like a Dalek, if you ever watched Doctor Who, the UK series, they may have a challenge there. So certainly some more innovation and development work to go on there. No one likes to talk about supply chain challenges, but we have to acknowledge that this is real world. And after the pandemic, it's kind of strange because things continued as normal for a period of time, but suddenly 2 years into or after the pandemic, there's container issues, things getting caught up in Shanghai, prices are going up. If we look at some examples here, I don't have my phone on me, but the same technology in the sensors of the camera that you use in optics as well. Are you going to serve a switch manufacturer, or are you going to serve Apple? So Broadcom supplies chips for both, and Apple bought up those chips, and ultimately it resulted in supply chain challenges. So as a manufacturer, what can we do about that? Just a couple of notes that obviously people's focus on supply chain is going to change. People always talk about cost, not value, or actually resilience in supply chain. So now that's flipping, and people want to know, if I'm doing an edge project, there's going to be a huge amount of edge projects compared to a large data center. Large data center, you've got 12, 18 months to plan it, ramp up for it, supply it. Edge data centers, and we're going to a case study in just a moment, it's a data center over 9 days, so small to medium-sized projects. It's all about the logistics and delivering on time. So when we look at product, we have to look beyond product. It's about the channel that supports you. It's about what you do with your product to make it modular to support this kind of new world order. So we talked about edge and where the edge is really happening for us. For the last 18 months, it did happen. We saw hyperscale investing heavily to put edge resources in co-location. Okay, so obviously we've seen some time now because of sovereignty and other factors, data, resources, power and compute moving maybe away from in North America into kind of regions a bit more. Last year and into this year, we were doing a project every 9 days with a very large hyperscale and predominantly one of the largest multi-tenant data centers. And this was about having the right products in the right place at the right time. It's all about the logistics. So a huge amount of projects, all about supplied over 20 different countries. Yeah? So a project every 9 days. This is what the kind of edge Panduit. Back up to the note in terms of supply diversity. The great thing at Panduit is that we have a lot of resources. We're having 9 manufacturing locations is redundancy in itself. You know, the ability to manufacture the same product in different manufacturing locations helps our customers get the products they need when they need them. And just to mention, obviously, a very strong channel partner community as well, helping us to service this client base. Just a quick question. Again, I'm talking about distance and fibre, and it's great to have the vision in mind with our leaders. I mean, when I first started as a young lad, I mean, we're not grey now, maybe kind of 30 years ago, people were talking about hundreds of metres, and I couldn't visualise it. And actually, the guy that taught me fibre was from the defence industry. Said, yeah, you know, we use kind of football pitches because you know we've got to determine whether it's 10 or 50 football pitches that we've got to aim over. So well, that's great. I'll kind of use that in my presentation. So, a quick question: how long is a football pitch? Does anyone hazard a guess in metres? 80. Anyone else? Because there will be a prize. Yeah, so essentially a football pitch can vary between 90 and 120 metres, depending on where it is. So you know, if you're as fit as me, or maybe I'm not as fit as I used to be, you might be running an extra 30 metres, but it's useful to keep that distance in mind. Because you know, typically within a data centre, traditional data centres, those distances you've got to reach between equipment are less than 100 metres. In hyperscale data centres, they can be often over a metre. Between campuses on a data centre, they can be kilometres. And we have to think about this when we think about the mode of fibre we use. So, in terms of fibre modes, there's multi-mode fibre and single mode fibre. And I could talk for hours, but I won't. I've got time, Martin, don't worry. So essentially, as a very high-level summary, multi-mode fibre will support a 1.6 terabit roadmap. Most importantly, thank you, the data centre, you know, there's an install base of multi-mode fibre that people want to, you know, that's an investment made like copper in the ground. It's just one telecom communication, it's there for a long time. So we want multi-mode fibre that we continue sales of it and support for it, and it will support this high-speed future road.